Hi, hey, I'm Miquel. I'm based in Berlin. I'm an Android developer, and I work for a company called Nebenan. We are a social network that connects neighbors. And we have lots of user-generated content. With the user-generated content, you will have the problem of emoji. When I started working at this company, if you ask me, what are the 10 most important things that you need to care about? I would have never put emoji on that list. And suddenly, we are having meetings to discuss how we can support emoji across all platforms. It ended up being more complex than what I thought, and that's what I wanted to give a talk about that. You can find the slides that I'm showing you now on Twitter, so you can go to my Twitter account, and you will find them there. Today, I'll be answering the following questions. Why is emoji relevant to developers? What do you need to know about that? What are the problems that we, particularly Android developers, face with it? And what are the solutions that we can find? And definitely, is emoji compat the best thing that happened to Android in the last years? Because last year at Google I/O, they announced Kotlin, right? And I was already using Kotlin, so it was like, okay, that's cool. But when they announced emoji compat, I was very, very happy. I was throwing away so much code, replacing by emoji compat. That pull request had like 100,000 lines out of code from my project. You will understand why now. But first, a little introduction to emoji. Emoji was invented in 1999 in Japan by a company called Docomo. And that's why you have things like the yen or like the hot springs symbol here. These are from the original emoji set, which was 170 emoji. And originally, it was a 12 by 12 icon, monochrome. And you will use it to, like when you send an email, when you send a message to a friend with one of these phones. So more device manufacturers started to also implement this. But there was no standard. So what was happening is that when you send a message to your friend and you say, hey, I would love to do this, and then you send an emoji, maybe your friend was seeing a different emoji, depending on the device that they had. It was not until 2010 when a company that starts with a name, with an A, let's say, from the United States, went to the Japanese market. And they said, no, we cannot do this. We need a standard. That's the time when Unicode got together with them to have emoji into the Unicode standard. And now we have more than 4,000 emoji. And all this original emoji has carried on onto this new spec. But talking about Android, I think it has been always backwards compared to iOS. If you check the first emoji set that we had on Android, it was monochrome. And also, the little Androids were really cute. You had like colorful emoji on iOS. And then the problem is that every version of Android, we had a different version of emoji also as well. So first we had the little Androids. Then we have the sideway blobs. Then we have the frontway blobs. And then we have now the round faces from Oreo. And I know that there are some blob supporters in the crowd, so I'm with you. So what big companies have done so far? In this example, WhatsApp. WhatsApp was, for me, one of the first big apps that was implementing their own spec, because they knew we cannot use whatever is on Android, we have to do our own. So WhatsApp was providing the same spec that you can find on iOS back in the days. And they provided their own custom keyboard for that. And you will see that the emoji from WhatsApp at the beginning was the same glyphs that you could see on iOS, and now they moved into their own implementation of them. Facebook, for example, is way more crazy, because Facebook had one emoji implementation for the Messenger app, and one emoji implementation for the normal app. So just imagine how big is a company that they can have two different emoji implementations. But now they have unified that. But they have, again, a different implementation because WhatsApp belongs to Facebook now, so it's complicated. But my motivation to give this talk can be summarized with these two screenshots here. What you're seeing is two API 16 emulators. One is running our website from Nevenan, and the other one is running our native app before doing any emoji support on it. Now try to convince a user to stop using the website and to install the app, right? So what can we do to improve this? Okay, we don't support API 16 anymore. I hope you don't have to do that also. But what happens with API 23? Okay? It's better, but we still have those problems, no? And I think you can probably see that we have lots of missing emoji here. So this is what is called a tofu. And a tofu is a representation of a missing glyph, of a missing emoji, but also can be a missing character from another language that you are not supporting on your app. And also we have the problem that the web users are seeing one emoji set which is different to the emoji set that we have. No, we have this is the emoji 1 font, and we have here the blobs, right? But the problem goes even beyond that. We not only have different implementations by the operating system version, but also every device manufacturer decides that they know better how to do emoji. So everyone has a different way of doing things. And why is always Samsung the one who is doing things differently, right? And this has been fixed so far as I know, but if you have an old Samsung phone, you can try it and to write a cookie emoji and see that you're seeing a salty cracker here. And it's the same thing that with the salad, that was this discussion, I know, about the salad, the egg in the salad, and so. And for me, it's very simple. The salad on other platforms is fully vegan. It doesn't have egg. No, in iOS, it doesn't have anything which is non-vegan, and on Samsung, it doesn't have anything which is non-vegan. So Google has to do the same. And you have to facilitate the communication between people with emoji that means exactly the same. No? Just imagine a Samsung user sending a message to someone with a cookie, with a cracker. It's confusing. It's not only objects have this problem, but also emotions that you can share with emoji can be different depending on the implementation that you have. So you have two users which are communicating to each other, and they are using the grinning emoji here. And how are you going to guarantee that what the user is trying to share with the other user is the same feeling? No, if they are one iOS user speaking with a Google Android user, they may be saying different things because of that. This is a very interesting article and can lead to a lot of discussions in the company about how to implement emoji. But before we go into the actual solutions, let's look into the technical part of the problem. First, a little introduction about Unicode. And I like to define Unicode as a single character set that contains all the characters from the universe. And I believe that if one day we find intelligence in another planet and they have a character set, we are going to incorporate it into Unicode because that's our goal. And each character of Unicode maps to what is called a code point. So, for example, the hello word, the H corresponds to one Unicode character, the E to another Unicode character, no, to one of these code points. But what is important to know is that this is not the way this is represented in memory. In memory, it can be different. Each code point can be encoded in a different way depending on the encoding that you're using. To give you an example, the H is the Unicode 0048, which in UTF-8 is a 48 in memory, in UTF-16 is a 0048. But it gets more complicated with an emoji. Here we have the tears of joy emoji, and this one is the Unicode 1F602. But the representation in memory has nothing to do with this number. It depends on if you are on a UTF-8 or UTF-16, it's going to be different. And sometimes the size that you are taking in memory is also different. Why is this a problem? You will see. In the case of emoji in particular, so emoji are graphical representations of one or more Unicode characters, code points. And in this case, the face with tears of joy is the Unicode 1F602. Now, if you go to Emojipedia and you search for this emoji and you copy it and then you paste it into Android Studio inside a string, this is what you will see. You will see the UTF-16 representation of this emoji. And then you set this text into a text view and the emoji will be rendered. But you can have more complex emoji than that. This is called the Woman Technologies medium dark skin tone. I will refer to this as just as a developer from now on. And when you go to Emojipedia, you look for this particular emoji, you copy it, and you paste it into your Android Studio project. All of this appears in the code. But it has a meaning. What you have here is a combination of different emoji that once they are all together, they get rendered as one single one. First, we have the woman emoji. And this first emoji is the one that will tell the gender of the emoji that you're going to render at the end. You can have woman emoji, man emoji, and also with the new implementation, you can have a genderless emoji. And in the future, we will have more options. You will have the person with beard, the person with the gray hair, and all these combinations. Then we have the skin tone modifier. And the skin tone modifier, what it's doing is, whatever I have before and whatever I have after, I want you to render it as one single thing. If it's compatible, then I want you to apply the skin tone modifier to what you have before. Now, this is interesting. This is called the zero width modifier. And this is a character that is never rendered, but what it's telling is, don't render these two things separated. Please try to render this thing as one single thing if it's compatible. That's a zero width modifier. And finally, we have the laptop, the computer. So when the system sees all of these together, and if it's supported by the system, then it will be rendered as one single emoji, the one that you see on top. Now, I have a challenge for you. You have to think, how many of these developer emojis I can fit on one tweet? Okay, think about it. So who thinks it's A? No hands. Who thinks it's B? One hand, 2, 3, okay. It will make sense, no? Since they originally supported 140 characters. And who thinks it's C? Okay, more hands. No, so for you, it's maybe easy to understand why it's C, but try to explain this to someone who is not into tech, right? They are writing the perfect tweet ever, and they want to add one last emoji, and they cannot. They don't understand. I have characters left. Why I cannot add this emoji at the end? So we have a 7 here, and we have 280 characters. So we can fit 40 of them. Where is this 7 comes from? So how you can measure the length of an emoji? We have here the emoji that I was talking about before, and what I will do as just normal developer is I will just use the string length. Now, what happens with the string length? The length is 7. So what we have here is these 7 characters, and the system is just telling me this is 7. Okay, but we were talking about code points before, right? There has to be an API that can tell me how many code points do I have on my string. That exists. And there is even a Kotlin extension that you can use, which is the code point count. You say from where to where you want to measure, and it will give you 4, because we have the woman emoji, the skin tone modifier, the zero width, and then the laptop. So the total is 4. It's still not what we want. We want to know there is one single emoji there. I know there's a lot of stuff, but I want to know how many actual emojis I'm going to be rendering. And the solution that I found is this one. It's really, really ugly, I know. And it's called break iterator, and it's not even an iterator. It does not implement the iterable from Java, so you have to do this thing. And you set the text that you want to measure, you start counting, you iterate until you are done, and then you have in the count, you have the result. Now, think for a second. What's the result here? If you're thinking it's 1, you're right. But if you are thinking something else, you're also right. Because it depends on the system. If the system is not able to support this emoji, the count is going to be different. And even if you're using Emoji Compat or a custom solution to display this emoji, if the system is not supporting it, the count will be incorrect. We have seen few challenges so far. We have missing emoji. We have different emoji per platform. And also, when we want to play with the strings, we have lots of problems with emoji. And now let's see some of the different levels of solutions that you can do to fix this. I will present you with 3 different solutions. First, a full custom solution. And this is something that Slack is going to be using, or WhatsApp back in the days. Then a custom solution with fonts, which is what we did at the beginning before supporting Emoji Compat. And finally, what is Emoji Compat bringing to you? With images and spans, the strategy is going to be as follows. First, we are going to search for all the emoji that there are on the strings. And we are going to replace every single emoji that we can find on a string by an image span. And then we are going to repeat this for the whole string. So you're going to need lots of things here. And of course, you don't want to create a dictionary of emoji by yourself. You don't want to add the 4,000 emoji into your project, but in an easy way. So what I recommend you to check is the Emoji One project. The Emoji One project has this JSON dictionary, which is huge, is 1.38 megabytes. So this is nothing that you are going to be able to parse all this information at the start of your project, of your app, let's say. On my first tries, I was using JSON to do this parsing, and it took a long time. So it was no option. So I found this JSONiter library. This JSONiter library was really fast parsing this. And then we found a solution in which we don't even have to parse this anytime. Because if you want to do efficient pattern matching, you want to use a regular expression. Someone said, with a regular expression, you don't have one problem, you actually have 2 problems. So this is how a regular expression that can match all the 4,000 emoji look like. Of course, we didn't type this by hand. We generated this from the JSON file that we had. And you can optimize this because there are regions that are the same, so you can make it nicer and smaller, but it still is something that you don't want to do by hand. It's something that you want to generate automatically. We have a way to find all the emoji on the string. Now we need to have these images that we want to show instead of the missing emoji. I would recommend you also to check the Emoji One assets, and they provide for free the PNG versions. And you probably don't need the SVG versions, so with the free version, you are already fine. And in this example, the slice of pizza, which is the the Unicode, 1F355, you will find it in the file 1F355PNG. So it's really easy to make the relation and to know what to load. Now we have the parsing, we have the images, we can build the solution more or less. This is conceptually what you will going to have. You have your pattern, you create a regular expression from it, and you use this regular expression to find all the matches in the text, okay? Here I have just a simplified version of the regular expression, which can just match for the pizza emoji. For every match, I'm going to create an image span that will be displaying this emoji that I'm missing. And this is how it looks like. Okay, so we had the pizza emoji, and the pizza emoji is now replaced by the image that we download from the Emoji One project. But there's a problem, right? It's too big. It's not at the same size as the text font, let's say, font size that we have. And also, you can see, maybe it's not even on the same baseline. So how can we fix that? You don't have to use an image span here. You have to use something a bit more complex, which is called the dynamic drawable span. And I will not be talking more about it, but you have a talk idea for next year's droidCon. You can talk about the drawable image span because it's a very complex topic. But this will allow you to resize the picture to the font size that you have and also to adjust to the baseline of the text. So your emoji will look just like a native one. It's a very complex solution. So the pros, in my opinion, is that you have a lot of freedom. So if you want to do something like a Slack, that you can have your own custom emoji, you want your users to upload emoji, this is the way to go, because you will have to do the parsing, you will have to do the rendering, and all of this. But it requires lots of manual work. If you're a two-person team, I don't see you doing that. Well, we could not do that, the two of us alone. And also consider, how are you going to manage 4,000 PNGs into your project? The second solution, and the one that we were using before using Emoji Compat, is to use a font file. And this font file, what you do is you include this font file into your project, you set this font into the text views in which you want to render the emoji, and then you set the text, so the font will take care of rendering the emoji that is missing. Again, use, for example, the Emoji One font. You go to the Emoji One download section, and there you can download the one for Android. Okay? There is one version for iOS, and there is one version for Android. And the difference is on the bitmap color encoding. So if you're using the iOS version on an Android phone, it may not work because of internals. So you have to download the Android version to be sure. You set that into the assets font, and then that will add 7 megabytes to your project. So it's quite heavy solution. You load it like you will use any other custom font with the typeface create from asset to the path of the font. You set the typeface to the text view, and then you set the text that you want to render. And this is how it looks like. So the joy emoji got replaced by the joy emoji from Emoji One, and the other developer emoji that we had that was broken now is correctly rendered. And we are using the Emoji One emoji set here. That's really cool, no? Because we had the same set on the web, now we have the same set on the app. I mean, for the users, that's perfect. But there are some little problems. So now, think about this. If I set this text into the text view, numbers 1, 2, 3, 4, what is going to be rendered? You will expect, well, it's just text, right? Numbers 1, 2, 3, 4. But this is what was happening. And that's something that it took me a lot to understand, that there are some characters that have a text version and an emoji version. And this is called the variation sector 16. So in this case, numbers and exclamation mark and the hash symbol also as well, all of them have an emoji version. And if you're just using a font, it's going to be rendering the emoji version instead of the text version. Even Emoji Compat has an option for you to enable this. So you can set on your configuration something that is called use emoji as default style, which will set the emoji to be always like this. You may want to do that. For example, if you're using the weather emoji in a weather app, the cloud that appears on Emoji Compat will be rendered like the cloud character in monochrome and not with color like the rest. Because of this, because that cloud emoji belongs to the group of this variation sector 16, so you have to change the Emoji Compat configuration for that. And this was a new API method that was released like 1 month ago, so it's really good that we have that now. So to fix this, with this solution, what you have to do again, you have to parse your strings, you have to find all the matches for all the strings that you want to, all the emoji that you want to render, and then you create a typeface span that is only displaying that typeface for that emoji that you want to render. So with a custom font, it's better and it's easier to set up, but it has some problems, right? We still have to do a lot of manual work. The cool thing here, of course, is that we have the same emoji as we have on the website. And it was a quick win to really just use a font that contains it. But 7 megabytes, and also you have to do the parsing with the regular expression. And finally, Emoji Compat. And the strategy with Emoji Compat is this. You have two options. You can either process the strings that you have calling to Emoji Compat process, or you can use the views that are provided already to you by Emoji Compat. To configure Emoji Compat, and this is still with the old school support library, but you can use also the Android X imports. You can try first with a bundled version of Emoji Compat that will add this font file to your project. And you can look into the build section of your project. You will find the font here. The font is called Noto Color Emoji Compat because this name, the Noto, means no tofu. That's the goal of Google by creating this font, that you will get rid of the tofu characters that you're displaying to your users. This also adds 7 megabytes to your project. So you want to use the downloadable version, but not only for that. To set up the downloadable version and create a font request, you need to pass these certificates here, which you may not have in your project. So to add them to your project, there is one trick. You add a custom font, an XML custom font, then that will create the certificates in your project, and then you delete the custom font, and then you have the certificates in your project. The documentation is not explaining that, so you get this for free from me. Create a font request for that and call init. But be careful. This init method takes 150 milliseconds to load. This happens asynchronously, but that means that if you use Emoji Compat immediately, like you have a really small app that is just loading and displaying emoji, it's going to crash. But there's a way for you to handle this. The best thing about downloadable fonts is that they also get updated. And you may remember this from Google I/O. And I think it's really interesting to go into this project here, the Google I18N Noto emoji, because you will see the changes that the developers are doing on the Noto project. So follow this project. It's really interesting to see the discussions. It's really interesting to see the pull requests that are changing things. And the commit that was fixing the cheeseburger, for example, that commit was on the 30th of October. And I was checking the version of the Emoji Compat Noto font that I had on my phone, and it was from the 30th of October. And it was like, OK, they fixed that, and it was delivered to all our users. You can check where are the fonts downloaded. And you can go here to this folder here, but you will need to have like root access to this. So you need either a rooted phone, or you need an emulator to do that. And yesterday I learned on the talk from Anita that these fonts don't get deleted. So if you are like requesting lots of downloadable fonts, your users are going to get all these downloadable fonts installed on the system. So I don't know if that will change in the future. But you can access there. You can download the font also. You can download a copy in your computer, and you can hack with it. And I was looking into the metadata of this font, and I found this timestamp here. So this is exactly what I was talking about, right? They did a commit, they fixed the cheeseburger, and I have the font that has the cheeseburger fixed here. To apply emoji compat to your text, you do the following. You call to process with a string that you want to add the emoji compat to it, to fix the missing emoji. And then you set the text into your text view. So this is how it looks like. Okay. The joy emoji is the same that we have, but the one that was broken is now the developer emoji. Cool. And this is from the official documentation. So all the broken emoji now becomes good. And what this emoji compat doing is creating an emoji span. This actually is called a typeface emoji span because it's using the emoji font that we had before. And it's replacing the broken emoji by the round face version. But this is from the official documentation. And in my opinion, this screenshot is wrong because it's actually like this. This is what is happening. You have the blobs and broken emoji, and now you have blobs and round faces. I don't think that's even better to have that. So how do we fix this problem? There is an option for you, which is called set replace all. And you will replace the blob emojis by round faces, so you can have the same user experience for all users, but also you can replace the Samsung emojis if you don't like them also as well, this way. I said before that it takes 150 milliseconds to init, so how can we wait for that? We use the register init callback method. This one will call immediately into the onInitialize when emoji compat is initialized. But when it's not, because you had an error, then it will call to onFailed. I don't really know how to handle the error here. And I was told, look, this is a problem in the place services loading the font. Don't worry about that. Just set the string. And most of the time, this throwable here is null. So there's nothing for you to report to Crashlytics, really. Just set the string as default, or if not, apply the emoji compat process. If you don't want to go with so much code, you can use the text view versions. And this is especially useful for the edit text version, because with edit text, you want to display immediately the emoji that you have on your app, and not just the emoji that the user is typing. So you will have to build a text watcher or use some kind of text helper to do that in a custom view. If you're using the emoji edit text or the compat versions, it's doing that for you. So for the edit text especially, it's really useful. With emoji compat, we had all these advantages, right? It's really easy for you. And I have a wish list of things that I would like emoji compat to be able to do. To customize it, I know that the Twitter team has been able to modify and provide their own emoji implementation by using emoji compat. But compiling a font to be able to be compatible with emoji compat is really complex because you have to generate a lot of metadata, and this metadata is not by default, so you cannot just take the emoji one font and bundle it into emoji compat. You need to generate this metadata. So there are scripts to do that, but it's not documented. And I know that the Twitter team was able to do that, and I hope there will be some official documentation soon. Also, what I want is an emoji keyboard that understands that if my app is using emoji compat, then I want to use also a keyboard that is displaying the same emoji from emoji compat. And also, I want tools that are able to tell me how long is a string, but considering emoji compat, not just considering what the system supports. And with this, I get to the end of the talk. Thank you. So I have some minutes left. I would like to show you this project. This is from a friend from here, from Berlin. And this is called the Family Emoji Project. This allows you to create these custom family emojis. And you click here on top, and then you can add a person, a family member. You can add the father, mother, kids, etc. You can set the skin tone modifier that I was saying. And if you want to collaborate into this project, this is open source, this website. And we would like to have also the, let's say, the genderless version, because it's also supported by Emoji. And at the end, you can copy the result, and depending on the operating system that you are, depending on the phone, then it will be displayed correctly, or it will be displayed separately, like in here. Thank you.